So we're going to be solving quadratic inequalities in two variables. Okay. So in the last lesson we were doing linear equations, or pardon me, linear inequalities in two variables. Okay. So now we're going to do quadratic inequalities in two variables. So we're still going to be shading regions. Okay. We're still shading regions. So you can put a little note about that. You're still shading regions. So let's take a look at this investigation. It's a short lesson. There's only an investigation in one class example because it's pretty straightforward. It's exactly the same as lesson 3, except instead of using linear, we're going to use quadratic. Okay, so this is very similar to the stuff that we did on Friday. So if you missed Friday, this lesson is very similar. So it says explain why the point is in the solution region. Well, we just have to test. This is a test point. This is an x value, this is a y value. You're all familiar with that. So don't be afraid to pump it right into the equation. Y is 0. X is 3. Solving that, you get 9 minus 9 minus 4. 0 greater or equal than negative 4. So then the test point satisfies the region. You can say that the test point satisfies inequality. And you say like therefore in the region. Okay, so if you've shaded the correct region and the test point is in there, you've done the right process. So they're just giving us a bunch of test points. Why don't we just test a couple? Let's test a couple. Okay, so let's take a look at this one. And just pick one at random. 2 comma negative 2. So let's go and plot that on the first graph. Where would that be? 2 comma negative 2. Right here. So right away, we can see that it's inside the quadratic kind of thing. So we basically what we can do is if you have different colors, is you can shade two different regions basically is what you can do. There's a region inside the quadratic and then there's a region outside the quadratic. So where does our test point lie? In the blue region, right? Let's pick one on the outside. Where's one going to be on the outside of that? 7, negative 1? Okay, so these 2 points. 7, negative 1 is in the purple, and 2, negative 2 is in the blue. So how do we know which one is which? Well, it comes down to this. Okay, so which one is blue and which one is purple? So taking a look, I'll use my pointer. Let's talk about the blue. Let's talk about the blue. Are we going to use y greater than this function or y less than this function? Anybody want to take a guess? I only heard one person say less than. I heard more people say greater than. So why greater than? Because it's above or below the curve? The blue is always above the curve, whereas the purple is always below the curve. So let's test out in blue. I'm crossing that guy out. Let's test out that point. What was it? 2, negative 2? Okay, let's test it out for above the curve. I like to use the words above and below. And I like to use the words curve for the function. This is like x squared, 3x, and 4. That's just some curve. Some curve on a graph. So we got to plug in 2 comma negative 2. So what's the y? Negative 2 greater equal, and then x squared. So we got 2 squared minus 3x, which is 3 times 2, x is 2, and then minus 4. Negative 2 greater or equal to 4 minus 6 minus 4. Those 4's cancel and you get negative 2 greater or equal to negative 6. So, can I make it bigger? Not really. So is negative 2 greater or equal to negative 6? So you say yes. I've shaded the correct region for above. Now switch to purple. Let's use our test point in the purple. So what was it? 7, negative 1? Is that right? 7, negative 1. Did I don't think I colored the right spot. I colored 6, negative 1. So let me erase that. 7, negative 1's over here. There we go. One spot over. Okay, so in purple, we are testing out the point 7, negative 1, which lies in the purple region. You can see it, it's right there. We just finished testing this point in the blue region, in blue here. So let's jump to purple. And testing this point, the y value, negative 1, is less or equal. Notice the difference. Originally we were doing greater or equal, now we're doing less or equal. So I would say that this would be like, instead of above, I would say this is below some curve. All the points, so in other words, what is the region below the curve? Okay, going to the algebra, we have negative 1, the y value, less or equal to x squared, so 7 squared, minus 3 times 7, minus 4, negative 1 less or equal to 49 minus 21 minus 4, negative 1 less or equal 24. Thank you. Is negative 1 less or equal 24? Yes, we've shaded the right region. Question? Will ever be like, we have dotted here, yeah. We have dotted quadratics? Yeah, absolutely. So the question was, could you have a dotted quadratic? And the answer to that is absolutely. So if this was strictly greater or if this was strictly less than, then we would use a dotted. Okay. Sorry? What if it was upside down? Are you talking about if the a value is negative? I think it's similar, above and below. And you can always use a test point. Okay, let's take a look at the notes. Notice from the investigation that the solution to the two-variable quadratic inequality is either inside or outside. So inside was what color? Blue, which I called above, and that was for greater or equal. And then outside, which I said was below, less or equal. This means that only one test point is required in order to determine the solution region. The following procedure can be used to graph the solution region of the two-variable quadratic. Draw the graph. So that's number 1. Using intercepts or other means like your calculator or completing the square or quad formula, all types of stuff we've learned from the quadratic unit. This graph will be solid or broken according to whether the inequality includes equal to or not. Choose a test point that does not lie on the graph. That's the important thing. Choosing a test point that's not on the graph. And if the test point does satisfy the inequality, shade that region, inside or outside. And if it doesn't, shade the other region. Okay, so let's take a look at this. So the first thing, we had to graph this. So imagine you were just graphing y equals negative x squared plus x plus 20. What are our options here? How could we graph this? Calculator? Absolutely. If you go the calculator route, my recommendation is you go second graph and look at the table and then plot some points. That's what my recommendation if you use the calculator. There's other strategies. What else could we do? There's complete the square. What does completing the square give us? The vertex. There's factoring or quad formula. What do those give us? X-intercepts. And what does the constant in the standard form give us? A y-intercept. Okay. All right, so I'm going to try and factor it. I'm going to take out the negative because I don't like the lead coefficient being negative. So negative is factored out. So that positive x becomes a negative x, and that positive 20 becomes a negative 20. And now I'm thinking that I could use 4 and 5 here. Minus 5 and a plus 4. So these will give me my roots. The roots are 5 comma negative 4. I can plot those. There's 5. There's negative 4. I know the y-intercept is positive 20. And I basically have some sense of the graph. Where does the vertex lie? You think it's the y-intercept? No. You know, it might be. I don't think it is. Notice that the vertex, and this is a nice little tip for quadratics. Some of you guys can't really complete the square nowadays because it's been a month. Just think about the vertex. Where does it have to lie between the x-intercepts? Where does it have to be? Is the vertex going to be here? 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 Why? The vertex has to be in the middle of the two intercepts. So what's the middle of negative 4 and positive 5? Negative 4 plus 5. Cut that in half to get an average. What do you get? 1/2? So when x is 0.5, you'll get the vertex. So you'll notice that the vertex does not happen at the y-intercept. So here's the vertex somewhere here. And then from that vertex, we can draw this quadratic. So there's a nice way to get the vertex without having to complete the square. You can add up the two x-intercepts and divide by 2. But that only gives me the x value. How would I find the y value? Could you plug it here? Yeah, you could put 0.5 there. Okay. Anyways, it doesn't really matter for the purpose of this question. Now, my question for you is, do I shade above or below for this inequality? Above the line or below the line? Less than. And did I draw my quadratic properly? Or should I have used a dotted line? So what's the best point to test? Okay, so test 0, 0. And you can always use 0, 0 unless what? Unless it's on the line, on the graph. Is 0, 0 on the graph? No, so we can use it. Plugging in 0, you get 0 less than 20. That was easy. Wasn't it? So if 0, 0 satisfies the inequality, should it be included in the solution region? Yes, so then we shade this region here. And that's an infinite region, as that graph is an infinite curve. Did I shade below or above? I shaded below, and notice the sign is less than. Okay, so less than will be below, greater than will be above. Sorry. Okay, let's take a look at this homework. Looking at the first one, above or below? Is the line dotted or full? Full. So we say y less or equal x squared minus 3x minus 10. Test 0, 0. 0 less or equal to negative 10. Is 0 less than negative 10? That's why that region's not shaded. The region that wouldn't include it is shaded. See how that works? So 0 is not less than 10. So instead of x, I'll put sad face. 0 is not less than negative 10. So we don't shade that region. Okay, let's take a look at this one. Do I shade above or below? Above. So y greater equal or just greater? Why just greater? Because it's dotted. The line is dotted. So we don't actually touch the line. So y is greater than this function, this curve. Now test a point. Test 0, 0. Should we expect it to work? No. So because it's not in the region. So 0 greater than 21? Because x is 0. Is that true? No. That's why that region's not shaded. Make sense? Kind of. Okay. Let's do some of these together. I will do part C for you. Actually, I'll let you guys do part C. C is a lot like class example 1. Actually, this whole question is a lot like class example 1. So let me just do one of them for you. Let's look at part B. Can we factor that? Well, whenever the sum differs by 1 on the product, you're probably just going to use the trivial factors. 8 and 1, right? And if they're both positive, this would be positive if they're both negative. So the solutions to the x-intercepts are 8 and 1. Now, does this parabola open up or open down? It opens up or down? Up, because the a value is positive. So the vertex is down here somewhere. Do I know where? I just know that it's halfway between 1 and 8. So what's 1 plus 8 divided by 2? So this is 4.5 comma q. I don't know what it is. I'd have to plug it into my formula to get it. But I just know what happens at 4.5. What's the y-intercept? 8 up here. So I know it looks something like this. Okay, so try to give yourself a decent sketch using your knowledge of quadratics from chapter 5. And do I shade above or below? It says y greater, so above or below? Above. And then test 0, 0. Is 0, 0 in my region? No, it's not. So that's why it's important to get a good sketch, so you know if 0, 0 is in there. So testing 0, 0, I got 0 greater or equal 8. Is 0 greater than 8? No. Notice it's not shaded. Okay, so finish off number 2 and 3. And the rest of this, it's a pretty quick assignment. Okay, you're more than welcome to use your calculator to help you with those sketches. Some of you, though, I would recommend trying to do it by hand without the calculator. Okay, and then how to solve this stuff using technology? Well, I don't really recommend the use of the technology, but I will show it to you nevertheless. So let's just jump into class example 1 for the technology. This is in the next lesson. It's just the very next lesson. This is page 530. So 2 situations you're going to get on the unit. It's either going to be linear, or it's going to be quadratic. Okay? We've already taken care of the systems, so there's a systems component to this unit and there's an inequalities component to this unit. So with the inequalities, it's either going to be linear or quadratic. So the linear on the left, just like in grade 10, math 10, you have to isolate into mx plus b. Mx plus b. But of course, you're not going to use equality. You're going to use whatever sign they give you. So I have 2x plus a 3y minus a 12 is strictly less than 0. I want to isolate my y. So keep the y positive. That's my recommendation. Keep y positive. That way you never have to divide by a negative, and you never have to flip a sign. So is he positive? So move the other 2 over here. What if this was negative? Just move this over and keep the 2 here. Okay? That way you never have to flip signs. Nevertheless, we have a 2x minus a 12. What am I doing? My bad. Keep 3y here, move the other stuff. So we got a negative 2x and a positive 12. Dividing by 3. Dividing by 3. And it's just like distribution. So we have negative 2/3 x plus 4. I prefer you to write it like this, where the coefficient is in front of the x, because that gives you some sense of the slope. So we go 3 to the right and 2 down because it's negative. If it was positive, we'd go 2 up. And this is the y-intercept. The constant is always the y-intercept. So we can start at 4. There's 4. And what do? 3 right and 2 down. So what's this point? If we started at 0, 4, we went 3 to the right and 2 down. So 3, 2. Now do I use a dotted or a full line? Dotted. And do I shade above or below? Below. Now we were supposed to use the calculator for this, which I don't feel helps at all. So watch what I have to do with the calculator. I personally don't feel it does much. So for the calculator, you have to get it into y equals format. So you still have to do that algebra. So what was it again? Negative. Thank you. Negative 2 divided by 3x plus a 4. Okay, my zoom 6, this is what it would look like if you were just graphing an equality, but we're doing an inequality. So what we have to do is we actually go over to the left here. See this thing here? See my cursor? It's flashing. It's like boom, 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 boom. To get over there, you just go left. See if you can get that thing highlighted. Now you keep hitting enter till you get the one you want. So which one do you think we want? Some of these are kind of fun. Like one of them's a key. It's like kind of, it like shows the key. It's like whoa. Like, you think we want that one? No, this one's sort of funny. So I don't really understand that one. But that was just for fun. The one we want is above or below. So I'm going to shade the one that looks, I'm going to pick the one that looks like below. See this one's below? And then there it is. Okay, this is graphing like the half plane. Okay. So there's that one. Okay? Okay, so the only thing that you wouldn't be doing on your calculator is graphing this by hand, knowing that that's the y-intercept and this is the slope, and doing that by hand. Okay. So let's take a look at what this would look like quadratic. Okay, here's quadratic. So looks like we have a polynomial that we're going to see if we can factor. What's the AC value here? Negative 30, and the B is negative 1. Can you think of one? Okay, good. Negative 6, positive 5. So that 2x squared minus 6x plus 5x minus 15. Grab some GCFs. We have 2x, x minus 3. Grab a 5. We have x minus 3. 2x plus 5 and x minus 3. So we have x1 is negative 5 over 2, and x2 is 3. So 1, 2, 3. Plot that guy. And negative 5 halves, negative 2.5, so 1, 2, 3, halfway right there. What's the y-intercept? Negative 15, so it's like way down here with my scale. Should be even probably lower, but whatever. And I know that the vertex is going to be somewhere close to that. So there's probably a minimum point down here somewhere. And I got the greater equal, so I'm going to have a full line. Here's my quadratic. Why isn't anything showing up on the screen? We're having a little of a server glitch. Come on. Wake up there. Snoozing. The iPad's snoozing. Holy. Server unreachable. There's probably too many people doing math on it at once. Okay, so my work is not showing up. All I did was draw a curve, and you didn't get to see it because looks like my Wi-Fi went out. Too many kids on here in the classroom probably eating up all the Wi-Fi. Oh man, we'll have to do what the book wants us to do anyway, which is use the calculator. So what was that original function anyway? 2x squared minus x minus 15. So we graph this. This is what I was trying to do. There's the 3. There's the negative 2.5. And then down here somewhere is the minus 20. Let me give you the, or was it minus 15? Minus 15. So let's go down to minus 16 so you can see it. There it is. Now, that's if you have equality. We don't want equality. What do we want? Above or below the line? What does it say, less or great? So then use this one. See how it's above? Greater. And then there it is. Okay? What do you guys think about that? Pretty sexy or what? You think this could show up on the next People magazine, hottest 20 in 2016 or what? All right, so that's the lesson. You're going to work on homeworks in both sections, and you're going to enjoy every moment.